Well, happy Taco Tuesday. Here, just the solution to a couple of questions from the homework as requested. I have 16.43 and then 16.46. So 16.43, I completely understand having some um, issues with. You're starting with 1.0 molarity of this solution, and it asks you what is the concentration of all species, so all three things, and it's hydrogen peroxide. It asks also what is the pH. One thing I notice is the Ka value, this 1.8 times 10 to the negative 12. It's tiny. So that tells me I'm going to be able to approximate on this thing. So the next thing I'm going to do here is this. I'm going to, my Ka expression is going to be this. Ka is going to be on the top, the monohydrogen attached to the peroxide, not really sure what to call that, times the hydrogen ion, and then on the non-dissociated hydrogen peroxide. Okay, so that's how we're going to write out Ka, and we have the Ka value. So now I'm going to come over to this side. I'm going to make an ice chart, and I've got the H2O2 here, that's 1.0, and it's going to be a minus X, so at equilibrium, it's going to be 1.0 minus X. And then here, both of these guys are going to start at zeros, and they're going to be minus X's. So they're going to sit there at minus X. All right. Big key here is that we can approximate because of that tiny Ka value. If we take concentration over K, in this case, it's going to be 1.0 divided by 1.8 times 10 to the negative 12. I didn't even bother doing that, but we know we can approximate. So that means I can squash something here. I can squash or get rid of this X here. I'm going to cross that off. So that's gone. And that makes me feel more comfortable. Next. What I did then was then I solved for Ka. And I did that. I'm sorry, I solved for the X value here. So at this point, we now have the Ka, which equals 1.8 times 10 to the negative 12 is equal to x times x, or x squared, over 1.0. Okay, so mathematically 1.8 times 10 to the negative 12 is equal to x squared, because I'm not going to bother to or I did multiply by 1, your call. So x equals here, I get a value of 1.34 times 10 to the negative 6. And that then is our x value. So what that means is, first of all, that will be our concentration. What's the concentration of all three species? Initially, this here, I would still call this as 1.0. These are now 1.34 times 10 to the negative 6, both of them. And the pH is equal to the negative log of 1.34 times 10 to the negative 6, which is our hydrogen concentration. So I get a pH value equal to 5.87. Okay, that is how we did that. Key points in that was that you could approximate, and that in order to get rid of the minus X from the initial concentration, and tiny Ka allowed us to do that. All right, hope that's okay. Now we're going to go to our next question. A solution of acetic acid has a pH of 2.54. What is the concentration of solution? In other words, what's the initial concentration? And I've got the Ka value here, which I put in your homework, of 1.8 times 10 to the negative 5. All right, now This is a bit confusing, but the one thing we do know is that if the pH is 2.54, then we know if we solve for the concentration of the hydrogen ion. So pH is negative log of the hydrogen ion, which means that H plus, the hydrogen ion concentration, is equal to the inverse log of negative pH is equal to the inverse log of negative 2.54. And in my messy handwriting, I got a value of, where did I get? Second question, 0.002884. As my hydrogen ion concentration. All right, now again, we've got our reaction. We're looking for the initial concentration here. That's our question mark or our X. We know the concentration of these two particles now. Okay, we cannot approximate though, because our K value, we don't know what concentration is, and we cannot approximate. So what we're going to do here is this. I'm going to set up our ice chart. And here we have the non-dissociated acid, the hydrogen ion, and the acetate ion. Okay. This is unknown. I'm going to call this Y. And the reason I'm just picking another letter out of the alphabet, because this is going to be Y minus X. So at concentration here, it's going to be Y minus X. Here, the hydrogen initially is 0 and it is plus X. So this is going to be an X, and so is the acetate. And I know what X is. This is my X value. It's hydrogen concentration at equilibrium. So therefore, X is equal to 0.0028884. All right, now let's set this up to solve. Ka is equal to hydrogen ion concentration, acetate ion concentration, or non-dissociated acid, like this. So initially then, I'm just going to plug in the X values. So it's going to be X times X over Y minus X. Now I'm going to sub in all the numbers I know. Ka is 1.8 times 10 to the negative 5 is equal to 0.0028884 squared, concentration of the two ions, over Y, the unknown concentration, minus 0.02884. So the next thing I did was just kind of flip it around, and I ended up with Y minus 0.0028884 is equal to 8.317 times 10 to the negative 6th over 1.8 times 10 to the negative 5, and all I did was flip them around. And then I simply went about solving, so I have Y minus 0.0028884 equal to, oops, sorry about that. I want to keep my annotations. And, yeah, thanks. There we are. Okay. I leaned on the keyboard. My bad. So I get that equal to 0.463, 462. And so I end up with X. I have to add that to both sides. And I end up with X equal to about 465. And the book rounds to 0.47. And that's our story. And that's what we're going to stick to. That is the molarity of the non-dissociated acid HC2H3O2. All right, that is how we solve them. I apologize for leaving the screen and then returning there at the end. Um, Again, questions and let me know. This one here, we hadn't really seen anything like it where you had to solve for the initial concentration, and that's how it's done. I'm definitely interested in you being able to do that because I think it's a really interesting skill to have. This question here, I think it's the reaction that's more funky than anything else. I definitely think it's a funky looking reaction. And but remember, when you've got these tiny Ka values, you can always approximate and get rid of that minus x on the bottom, and then you're just sort of an algebraic solving of it. Okay, I hope this was a help. I hope you're enjoying your Taco Tuesday, and that hopefully this is the last announcement for today. And that tomorrow there is no new assignment. You have the assignment for that. It is a remediation day. If you're taking the AP test and I interrupted you, I'd be mortified. But focus on that. And if you're taking AP test, let me know. People have been doing that, and I really appreciate it. Hope this helps. Take care. Bye bye.